This is a great question. We've been given a radical expression and we're being asked to rationalize the denominator. Basically remove all the square root symbols from the denominator and then simplify it as much as possible. Now this is not a function or an equation. There's no right hand side, left hand side. So we're left just with what we have to try and follow these instructions. I'm going to use the difference of squares. And notice I've got a minus here, which means that if I multiply, I'll explain the numerator in a moment. If I multiply the denominator by the same expression but with a plus, I'm going to be able to get rid of the square roots, and I'll show you why. And if you remember the difference of squares, you already know why. Let's try this. 2 times the square root of 3. Well, I'll just write it like that with a square. There's 2 of them. And we'll do plus 2 square root of 3 times 3. I'll just leave it like that. Then we've got negative 3 times 2 times the square root of 3. And finally, we've got minus 3 squared. 3 times 3. Notice that the plus and the negative are going to sum to 0. So we're going to be left with Now I have completely forgotten the numerator, so let me rewrite this out. We've got negative 4 times this thing right here. Right? As long as I multiply the numerator and denominator by the same value, I don't change the expression. And that's divided by this thing. Now I'm going to work through the exponents. So I'll write the numerator as is. And I've got the square. So 2 squared is 4. The square root of 3 squared is just 3. And that's going to be minus 9. Now I'll work through the numerator as well. So I'm going to have negative 8 times the square root of 3 minus 12. And that whole thing is going to be divided by 12 minus 9. And over 3. And I look at the numerator. I guess maybe I should not have brought the 4 into the bracket, so I can factor out a 4. I'm going to have negative 4 square root of 3 minus 3. That whole thing is going to be divided by 3. And I just realized that I made a little mistake here. I forgot a 2. I should have had a 2 in front of this and a 4 here, like so. And I'll just redraw that thusly. Now when it comes to ALEK doesn't like these brackets, so this is the answer that ALEK would like. Let's look at this next question, which is asking us to simplify a higher radical expression. So again, we've got no left-hand side, right-hand side, there's no equality, it's not a function, we just have to work with what we've been given. So to get started, I will find the hardest part with these questions is what to do with numbers, numbers like 48. So why don't I break 48 up into the smallest factors possible. So I'll rewrite the cube root 4 like so. And I know that 2 divided by 24, or excuse me, 48 divided by 2 is 24. So that would get me 1, 2. And then with 24, I could have 6 times 4. And then maybe I'll just take a little break. I don't want to do too much in my head, because if I try to do too much in my head, I'm most likely, or more likely, to make a silly mistake. Now let's keep going, because we can break this up even further. I've got the 2. 6 is 2 times 3. And 4 is 2 times 2. So we've got S19 here and T12. Now I've got a 4 up here, and I've got 1, 2, 3, 4 4s, or excuse me, 4 2s. So I can sort of bring out those 4s, or maybe I'll rewrite it like this as an intermediate step. I'm going to use our exponent rules to break up this 4th order root. And remember, the rule is something like, well, if I've got x to the power of a multiplied by y to the power of b, and I've got this whole thing raised to, say, the power of c, that's equal to x ac times y bc. And so that's the exponent rule, or one of them. Now looking over here, we got 4 squared, and I want to take the 4th root of that thing, so we're just going to be left with 2 on the outside. You know, it's kind of like having 4, this thing to the power of 1 over 4. And so we get 4 times 1/4, which is equal to 1. Oh, I forgot that this 3, so we should have a 3 in here. I'll add it to the end. And I've got S 19. I can just rewrite it like that in exponent form if I want, and I've got t to the 12 over 4, and I've still got the square root of 3. Now rewriting this, so I've got 2, and outside the bracket, or maybe I'll just write with the whole number exponent, I'm going to write s to the power of 4. Or maybe, to make it a little more clear for you, I'll write it as 16 over 4. And you can see 12 divided by 4, well, that's obviously to the power of 3. Now I've still got s to the power of 3 over 4 remaining, so I can put it back into the cube root like so. And then rewriting this kind of ugly thing, I've got 2 s to the power of 4 t to the power of 3 times the 4th root of 3 times s cubed. So here we are on ALEK's. The question is asking us to put the following expression in simplified radical form. So we're allowed to keep a square root. We just need to simplify it. Now I'll put in our answer. So we had 2 times s to the power of 4 times t to the power of 3. And here I'm going to use this expression here, the one that's highlighted in blue. And if I click on that, it's going to let me do an nth order root. So I've got a 4 there for the 4th root. And then I hit the right arrow key. Now I'm inside the bracket. 3 times s to the power of 3, or s cubed. Now we're on the outside, and I'll click the check button. And we have the right answer. We're given an expression where we've got one radical subtracted from another radical. We have no equal sign here. We have no left-hand side, right-hand side. It's not a function. It's not an equation. It's just an expression. And so we have to simplify this as much as possible. Why don't we start by doing what we did last time? And let's start with the numbers. So we've got y to the square root of 50. Well, I know that I could rewrite 50 like so. And I'll just leave the x cubed in there. Minus 9x. And we've got the square root of, well, I can't do anything with 2. So I'll just rewrite the right-hand term. Now, going back to the next line, we've got y. Well, y is just going to sit out there for now. That x cubed, I can do something with that. I could bring out an x squared. And if I bring out the x squared and take the square, I should say if I take the square root of the x squared, I'm just going to have x. And now I've got, oh, and now I can take out, I can take the square root of 25. So I've got 5 like that. And what's left in here is 2x. Over here, we've got 9x. I can take the y out, so now we've got the y there. And because the y squared just becomes the square root of that is just y. And we've got 2x in there. And that's kind of handy, because now I've got a square root of 2x on both sides of the equation. So why don't I factor out the square root of 2x, and I'm going to be left with 5xy minus 9xy. And now I can factor out the xy. So we've got xy square root of 2x times 5 minus 9, and that gives us negative 4xy square root of 2x, which looks like it could very well be the answer. Why don't we put it in ALEK's and see if it is the answer. Here's ALEK's. I'm putting in the number, or I'm putting in our answer, negative 4xy. And here's the square root symbol that I want to use. And we've got 2x down there. And I click on the check button, and we got the right answer. We've got a square root of y here, and we've got a y to the power of 1. So I suspect two solutions exist. Right? Just like if I have y squared is equal to 4, that's like y is equal to plus minus 2. Right? It could be minus 2 or it could be plus 2. So let's go ahead. I've got the square root on the entire left-hand side. So one thing I could do, and I'll do this so just to, again, to help you look at it, I could rewrite this whole thing like so. Now, if I want to collect sort of like terms, I don't really know what to do with the square root of 4y minus 7. So one thing I can do to try and make this easier to work with and get to the answer is I can square both sides of the equation. I can square both sides of the equation. And if I do that, exponent rule says the 1/2 is going to be multiplied by the square, the 2, and then I take the square of this whole thing. Remember, common student error, y minus 3 squared is not equal to y squared minus 3 squared. Right? In general, that's not true. And specifically here, it's not true either. Now, what have we got? We've got on the left-hand side, we just have 4y minus 7. That's nice. I can split up the terms. I can work with the 4y and the negative 7 separately. And on the right-hand side, I've got this y minus 3, that whole thing squared. I want to open up the bracket, what I call opening up the bracket. And if I do that, I'm going to have y squared, and I know I'll have 6y, because this is a special kind of equation that I've memorized the answer to. Most people have memorized the answer to, plus 9. Right, 3 times 3. You can work it out if you want. Do the FOIL method, as ALEK explains to you, but I know what the answer is going to be that. Now, what do I want to do? I've got a quadratic. So I want to set this thing equal to 0, and then I can solve it by factoring, or I can solve it using the quadratic formula. And I want to collect like terms here and set the whole expression equal to 0. If I do that, I'm going to get y squared minus 10y plus 16 is equal to 0. Now, how can I have two numbers that sum to negative 10 and that multiplied to each other is equal to 16? Well, if I've got y minus 8 and y minus 2, I'm going to be able to factor that quadratic expression. And I can see here that if y is equal to 8 or y is equal to 2, I should say the equation is true. Wait a second. Are we sure that this equation is solved when y is equal to 8 or y is equal to 2? Well, let's give it a try. If y is equal to 2, then we get 4 times 2 minus 7 is equal to 2 minus 3. And we end up with 1 is equal to negative 1, which is a contradiction. Y equals 2 is not a solution. How about if y is equal to 8? If y is equal to 8 times 4 minus 7, the square root of that whole thing, is equal to 8 minus 3. We've got 32 minus 7 is equal to 5, which is the square root of 25 is equal to 5, and 5 equals 5. So y is equal to 2. Y equals 2 is not a solution. We already said that. Y is equal to 8 is a solution. So there's only one solution here, not two solutions.